Good morning once again, class. We're recording our session for today, which is about introduction to multiple linear regression. So let's first open a new project here. So you know how to open a new project, and let's open it. Okay, let's open it in an existing directory. Yung directory natin that we created, remember I created it in my desktop. I think I named it COB516, or I don't know in your case, but let me open this. This is the existing directory. Okay, let me resend the files. And also another one. Let me just transfer that file also. Okay. I think I made the mistake. Okay, let me create a new one class. No? File, new project. Okay, I'll just put it in a new directory. Okay, new directory, new project, and then here subdirectory. I'll put it under the. Okay, so that's a mistake I made. I'll put here in this subdirectory our project COB516517 open. Okay, and then I'll call this multiple linear regression. Okay, so were you able to follow, class? What I did was to open new project and then new directory and then new project, and then I placed it under the subdirectory which we created last time, our projects COB516517. I'm not sure if you used this name also. Okay, and I'm going to create a new directory, multiple linear regression, create project, and there. Okay, so if I take a look at my folder here, I created this new project, and I'm going to transfer the files there. Okay, so the project is multiple linear regression. Okay, and then if I open again my R file, you'll notice now that under that project, multiple linear regression, are the two files that I shared with you, wage and the basics of regression workbook. All right, so let me let me give you a few seconds to work on your project. Our project, you can call it multiple linear regression. I think that's a good title for that. And then if you're done, class, kindly chat if you're ready. When I say ready, you have already this project open, multiple linear regression. And then you can see here on the files, you should have wage and the basics of regression. Okay, thank you. Done. Okay, good. Done. So let's wait for the others. Should you have any questions, please feel free to ask. Okay, thank you. So let's see. Min is okay. Nadine, Kara, Wilson, Ruby, Mary, Marjorie. Okay. So just a few more seconds to allow the others to be on the same page as us. Okay, Michelle, thank you. Alvin, okay. Anyone not done? Mark, okay. Anyone who needs a few more seconds to load the data and the file on inside the project multiple linear regression. Okay, I think everyone's done. Everyone's ready. Okay, so this is our project multiple linear regression, and in that folder we loaded our data and our workbook, right? Our RMD file. So we can click this, open that. Right. So this will be our introduction to multiple linear regression. So let me hide the outline here. Okay, so we're working with an RMD file. Now next meeting, we'll start to work with the QMD file. All right. All right. So send ko ulit yung, wait, huh? Okay. Let me close this first. Okay, I cannot send the file if it's if it's open. So let me close the file first, and then all right here. Okay, sent. Okay. So let's continue, class. Let me once again open the file. Okay. Right. Our topic for today is a very important statistical tool, analytical tool, and it's called multiple linear regression. Okay. Linear regression. The focus of our subject is multiple linear regression. There's such a thing as simple linear regression. Okay, maybe that will be our. I'll explain first simple linear regression, and then of course move on to the multiple linear regression. All right. So as I just used some descriptions here. It's number one. It's a statistical technique. Okay, it's used in order to analyze variables. In multiple linear regression, we would like to see or to explain a particular variable using other variables. We would like to describe that variable, making use of other variables, and then also to predict that particular variable using the other variables. So the variable of interest, the variable that we're looking at, is what we call dependent variable. Okay, there are other names for this. It's also called your explained variable or your response variable. Okay, so there are many names that are used to describe your dependent variable. And those variables that are used in order to explain our dependent variable are called your explanatory variables or independent variables or predictor variables, etc. Okay, so the goal of a multiple linear regression model is to find if there's a relationship between your explanatory variables and your response variables. Okay, is there a statistically significant relationship between them? So that's in essence the question that we would like to answer in a multiple linear regression model. The method that's used, okay, the method that's used is called OLS. So the method that's used for coming up with the multiple linear regression is the ordinary least squares method. So let me first explain what the OLS is all about. So what's the OLS? What does an ordinary least square mean? Okay, so let me just start with a simple, okay, multiple simple linear regression. By the way, the difference between multiple linear regression here, multiple, and a simple linear regression. Simple linear regression. Let me see if I can use my, this was not working yesterday. I hope it's working today. Good. Okay, okay, it's good. It's working. Simple versus multiple. So what's the difference between them? When we're using a simple linear regression, we have only one independent variable that we're using to explain a dependent variable. However, when we have multiple linear regression, we have several, more than one independent variable that we're using in order to describe our variable of interest, our dependent variable. So that's the difference between them. Now, the method that's used in this model is what we call the method that's used is OLS. So this stands for ordinary least squares. Okay, so let me just briefly explain what this is so that we know, at least we have an inkling of what this OLS is all about. So if I'm going to plot our dependent variable y, usually this is our dependent variable on the y-axis, and then on the x-axis is our independent variable. So we're using x in order to explain y. When we plot this, for example, we plot the points. Okay, this one. So how do we create a model so that we're able to explain y using x? And how can we predict y using x? In order to do that, we have to come up with a mathematical model. Okay, and that model is called your regression. Depending on the relationship between y and x, it will usually form a line. Okay, so that's why it's called linear. Okay? Linear regression. So if we're establishing a model, creating a model to define y using x, then most probably we think that the best model will be this one, this line. Okay, definitely it will not be this line or this line. Okay, now how do we determine what this line is? Okay, this line, this specific line is determined using this model, this method, ordinary least squares. And how is it done? What we do is we get this line and then we look at the what we call the residuals. So if this was our line, this is our actual point. So this height here, these heights here are what we call our residuals, aka error terms. So which means that this is the actual value and this is our regression line. So we quote unquote missed the mark. So these are our error terms. So we have several error terms. Okay. Now this line, the OLS line, or AKA it's also known the line of best fit. Line of best fit. It has one characteristic. The characteristic of this line is that if you add up all the error terms, okay, number one, the sum will be equal to 0. Okay. Secondly, the sum, okay, what we do is this line, this specific line, this red line, when we add up all the residuals and then we square them. Okay, so we have sum of your residuals squared. Okay. We square the residuals. It will be a line where the residuals are at a minimum. So minimum yung residuals, the sum of the residuals. Okay, the square of the residuals. I mean, if it was this line, then the residuals will be very, very high, right? So the distance between this line and your actual points, if we plot the residuals and then square them, the squared residuals will be very high if we use this line. If we use this line, same thing. If we use this line as our line of best fit, same thing. The squared of the residuals will be very, very high. Okay. Now, the nature or the characteristic of this OLS line, ordinary least squares line, is that it is unique. When I say unique, there's only given these points, given these observations, you can only have one and only one line of best fit. Okay? There is no other line that best describes your y using x, given the points. Given these points, given these observations, you only have one unique line of best fit. And that line, when we get the residuals, the difference between that line and the actual data points, the error terms, and then square it, that's why we call it squared. No? It gives us the least sum of the squares of your error terms. Okay, that's why it's called OLS, ordinary least pinakakonte squares, that refers to the square of your error terms. Okay, so that's the whole concept of OLS, ordinary least squares. We find this line that will best describe our y using x. Okay, and that line has a characteristic where if we plot the difference between the actual data points and this regression line, and then we get the squared of those error terms, it will be a minimum. When I say minimum, you cannot find any other line whose sum of the residuals squared is lower, is smaller than this line. Okay, so let me pause for a while. Is that concept clear, class? Clear ba yung OLS, ordinary least squares na method? Kindly chat, please, for feedback. If you have any questions, feel free to Okay, thank you. Good. Feel free to ask questions, class, if you have any. All right, so let me clear the drawings now. Let me close this. Okay, so that's the method that's used. Of course, we will not go into the mathematical way of doing it. We will be using R itself in order for us to compute for this line of best fit. Okay. All right. Here you have the equation. Okay, for a multiple linear regression, and this is, by the way, what we call LaTeX. LaTeX. This is the way to write equations. Okay. This is LaTeX. Okay. It's pronounced as tech, not text, because X here is Greek, XC. That's chi. So it's called LaTeX, just like technology. Okay? Chi square. So it's not the Roman X. Okay, so this one, I will not be discussing this, but you can do some research about how to write equations like this. Just suffice it to say that I began with $2 signs and ended with $2 signs. So that means this is the start and this is the end. Okay, here begin aligned. Okay, so if you take a look at this, everything is aligned here below. Okay, anyway, what's important is the content. So here you have beta null plus your y sub I, our y is equal to beta null plus beta 1 xi1 plus beta 2 xi2 plus beta 3 xi3 plus etc. beta n x sub I n plus epsilon sub I. Okay, what's this? This is your regression line. And this establishes the relationship between your y, your dependent variable, and your independent variables. Okay, your independent variables are x1, x2, x3, x4, xn. So n here refers to the number of explanatory variables that we have. The I here refers to the ith observation. So for example, we have 20 observations. Then you have y1, y2, y3 up to y20. Okay, y1 will correspond, of course, to the observed value for x1. Okay, the I here will be 1. 1 here refers to the first variable. The 2 here refers to the second variable. The 3 refers to the third variable. And n refers to the nth variable. And notice we have here beta 1, beta 2, beta 3. Betas are your slopes. Okay? So in order to establish a regression line, you have this equation where your beta 1, your betas, refer to the slopes. Okay? So these are the marginal effect of this specific variable on y. Okay? This beta 2 is the effect of variable x2 on y, etc. Okay? As I said, y sub I is your dependent variable. X's are our explanatory variables. Beta null, you notice beta null does not have an x here. It is your y-intercept. Okay? It's your y-intercept. It's your constant term. And as I mentioned a while ago, beta n are the slope coefficient for each explanatory variable. Okay, and then epsilon sub I is your residual or your error term. So remember y sub I, okay, for y you have your actual value and then you have your model value. Okay, the difference between your actual value and your model value is your epsilon. That's your residual. All right. So let's take a look at certain assumptions. Okay, these are very important for us to know. There are certain assumptions as far as multiple linear regression is concerned. The first assumption is the data should be linear. The relationship between your y and your x's should be linear. So let me once again explain that. Okay. So once again, let's go back to our, okay, plot y and x. Okay. If we plot y and x, they should have this type of a relationship. Okay. It's a linear relationship. Okay. So hindi pa pwede yung relationship na medyo quadratic yung ganyan. So if y and x behave this way, the relationship is more quadratic rather than linear, then we cannot use the multiple linear regression or the ordinary least squares, multiple linear regression model. Why? Because this uh, this here tells us that there should be a linear relationship between your dependent variable and your independent variable. So if the relationship is like this, or maybe it behaves somewhat like this, so there's a maybe polynomial relationship, then using a linear model might not work. Okay, it will not work. If the relationship was this one, if it was this one, then that will be okay. You can establish a linear relationship. But if it's this one, like that, then a linear model to explain a relationship that's more quadratic will will generate many residuals, okay? And the power of x to explain y will be very, very low. Okay, so we don't want this. We don't want that when we plot our data, that the relationship between your dependent variable and your independent variable is like this. If it's like this, then we have to use another model, not a linear model. Okay, so that's the first one. Okay, linearity of the data. The relationship between your IB, independent variable, and your DB, your Y, can be characterized by a straight line. Okay, if they are not linear, then it will not be a good. Okay, it will not be good for us to make use of a linear model. Okay, the next assumption is that there should be the linearity of the parameters. Okay, what does this mean? A while ago, I showed you the equation, right? This one. When we say linearity in the parameters, the betas here, the parameters, these are called the parameters, beta null, beta 1, beta 2, they should be linear. Linearity in the parameters. Let me elaborate further. Let's take a look at this one. But we have here yi is equal to beta null plus beta 1 squared. You notice that beta 1 here is squared. Okay, or it can be that beta, let's say beta 2, si beta 2 naman naka-square root. Si beta sub n naka-log. Okay, tapos siguro si beta, let's say beta 3, naka-1 over beta 3. Kasi pag 1 over beta 3, it's equivalent to beta 3 to the negative 1. No? May exponent din na negative. Okay, so now for a linear regression model, our parameters, our betas, cannot be expressed this way. They should just be plain beta and should not carry log or square root. Now, why is that so? Because it will be quite difficult to compute for the parameters if you have a structure like this. So hindi pa pwede yan, no? So dapat on the other hand, class, yung dependent variables natin, kunyari ito, it's perfectly fine na naka-square root siya, naka-squared siya, naka-log siya. Okay? Okay lang yun. No problem with that. Okay, but not this. The betas should not be, okay? As we said a while ago, hindi siya pwedeng hindi siya pwedeng hindi linear. Dapat linear lang siya. Okay? Let me pause for a while. Is that clear, class? Yung second na assumption natin? As far
Yes,
as...
sir.
Okay, thank you. How about the others? Okay, thank you. Okay, third, homogeneity of the residual variance. Okay, a while ago, I told you, I said that when we create a model, an OLS model, there will be, of course, residuals. There will be a difference between your actual value and your model value or your predicted value. Okay, so it's important then when we collect these residuals, when we plot them, when we plot the residuals, they should be behaving like this. So for example, again, this is our plot, this is our x, and these are our residuals. Okay. Residuals, no? When we plot our residuals, they should be random, like this. Okay. They behave. Okay, yung variance nila, yung variance nila dapat constant, no? So, ito yung sinasabi natin, homogeneous. Homogeneity of the residuals variance. Okay, when we plot the residuals, they should behave this way. This means that the residuals, you have a constant mean, constant average, and a constant variance. What's the difference between a constant variance and a non-constant variance? Pag hindi constant yung variance, then ganito yung behavior ng residuals natin. Okay, it will be increasing across the value of x. So pag ganyan, hindi constant yan, no? Kasi if you take a look at several at different points in x, iba yung ano nila, iba na yung variation niya. Pagdating dito sa simula dito, lower values of x, ang variation niya ganito lang, no? But as we increase x, the variation now in your residuals is like this already, diba? So this is what we call a fanning out. Parang fan, F-A-N, no? Parang abanico, no? So kapag ganyan yung residuals natin, class, then hindi acceptable yung model natin. This just means that there is something in the model, in your variables, in your y, that has not yet been captured by x. Okay, so this is what we call non-constant variance, and there's a name for this. We call this heteroskedastic. Heteroskedastic residuals. Okay. On the other hand, yung gantong klaseng variance ng residuals, yung nasa yellow, it's called your homoskedastic. Skedastic means spread out, no? Homo means the same, no? Constant yung pag-spread out ng residuals natin. Hetero means nagbabago, no? It's changing over across your independent variables. Okay? So after we model, we will have to check the validity of our model. Hindi pa pwedeng na-model natin, nakapag-create na tayo ng linear regression model, tapos na. No. We don't stop there because we have to do what we call diagnostics. We have to diagnose our model and see if indeed it is consistent with the assumptions of the classical linear regression model. Otherwise, we will have to do something. We will have to remedy the situation. Okay? So clear ba, class, yung homogeneity of residual variance? This is what we call homoskedastic residuals, no? O yung variance niya homoskedastic vis-a-vis heteroskedastic. So either fanning out or fanning in, pwede rin namang pag ganito yung variance, baliktad. Okay? Or pwede rin yung variance natin, hindi nga fanning out, pero pag ganito siya, parang line na pag ganyan. Kasi pag ganyan kasi residuals natin, class, ibig sabihin nun, what does that mean? It's increasing over time, di ba? Right? So hindi siya constant. So this is a type of residuals that's not constant if your residuals behave this way. Okay, so sabi natin, our residuals should be fairly constant across the values of your predictor variables. Okay, pause again, class. Clear so far? Clear ba yung, sorry for my crude illustration there? Clear?
Yes, sir.
Okay, thank you. Thank you. Okay, nakalimutan ko mag... Okay, so also in relation to that, ito, punta muna tayo sa 5 dito. In relation to that, yung independence ng residual error terms natin. When we say dapat yung residual terms natin, residual error terms natin independent, it means that when we plot it, dapat random lang siya. Yung kanina, diba, plinat ko random siya. Ibig sabihin nun, class, okay, let me do that again. Ano? Ito yung residuals natin. It's random, no? You cannot establish a relationship between your residuals. Yung sinasabi dito na independence, if your residuals behave like this, may dependence yan, di ba? Among each other. They are correlated, yung mga natin, yung mga residuals natin. So kung correlated sila, hindi sila independent, they are dependent. Okay, that's why this independence of residuals can be explained, can be shown via the distribution of the residuals. Kung yung residuals natin ganito, random lang siya, okay, constant mean and constant yung variance, then independent sila. If your residuals were behaving like this one, so may pattern siya, umaakyat, hindi independent yun. Dependent yung residuals natin. Okay? And also, normality of residuals. So yung tatlong yun about residuals. Number 1, constant mean and constant variance. Number 2, independent dapat sila. Number 3, the residual should be, when we plot it, it should be normally distributed. Okay? So those are the 3 important criteria for our model for it to be acceptable. Okay? And also there's this last one. Explanatory variables are not collinear. Okay, we want the, so let me explain that carefully. We want that, okay, si X, si Y, at saka si X, gusto natin correlated sila. Kasi kung if X and Y are not correlated, then how can we use X to explain Y? So we want a pattern like this. When if you're trying to explain Y using X, we want that there should be a relationship. So dito may relationship, may linear relationship. Okay, that's between Y and X. However, we do not want that X and X, your independent variables, to be related. Okay, when we plot X with X and then we see this, hindi maganda yun, class. Kasi that's what we call collinearity of your explanatory variables. Now, why is this bad? Why is this bad? Why don't we want your independent variables to be collinear? We don't want them to be collinear because we will find it difficult to try to see what's the contribution of this x1 in explaining y, and what's the contribution of x2 in explaining y. So there we will find it difficult to try to segregate the impact of x1 on y and x2 on y. Because isn't it that's the multiple linear regression line? Each of these will have their own betas, their parameters. Si x1 may beta 1 yan. Si x2 may beta 2. And these betas are the slopes and they measure the impact of x1 on y. Si beta 2 then, it measures the impact of x2 on y. If x and y are correlated, then there will be difficulty as far as determining yung betas nila. Let me give you an example. Let's suppose x1 is, kunyari, 3, 2, 1, 5, 4, example, no? Tapos sa x2 will be 5, 3, 1, 9, 7. Okay, what do you notice about these two? These two are what we call perfectly correlated. Bakit sila perfectly correlated? Kasi x2 is derived by multiplying x1 by 2 and then subtracting 1. So in other words, x2 is equal to twice x1 minus 1. So ito yung perfect relationship nila. So 3 times 2, 6 minus 1, 5. 2 times 2, 4 minus 1, 3. So this is, ano ba ito? 1 ba ito? 1 times 2, tama. 1 times 2 is 2 minus 1, 1. Right. Okay, so ito, si x1 at saka si x2, if we use this as predictors of y, then we will have a problem. Kasi they're perfectly collinear. So, paano natin malalaman kung ano yung impact ni x1 kay y at saka impact ni x2 kay y if practically they're the same, right? Okay? So, we don't want the predictors to be highly correlated. Okay? In this case nga, perfect collinearity to eh. Lalo naman to, di ba? So, high correlation is not good. All the more perfect collinearity, hindi pa pwede yan. So as we said here, multi-collinearity exists when two or more of the explanatory variables are highly correlated. This is a problem as it can be hard to disentangle. Which of them explains what portion of the outcome variable? So hindi natin malalaman kung ano ba yung ina-explain ni x1 about y, ano ba yung ina-explain ni x2 about y when they are perfectly correlated. In fact, magkaka-error yan. No? Okay? So, any questions so far? About, let's just repeat class, no? Number 1, dapat, linear dapat yung relationship ni y at saka ni x. No? Which we already discussed. Ayaw natin na si y at saka x quadratic or polynomial yung relationship nila. Our model will not work kung ganun yung relationship nila. Second, sabi natin, dapat linear in parameters. No? When we say linear in parameters, yung mga betas natin in our models, they should not be squared or they should not be cubed, raised to a certain power, or may reciprocal siya, 1 over beta, hindi pa pwedeng ganun. Linear lang dapat. Okay, number 3. Ano sabi natin? Constant, yung about the residuals, tatlo yung sa residuals, no? Constant mean, constant variance yung residuals. Hindi pa pwede nag-fan out yung residuals pag prinat natin. Fan out, fan in, or may trend, akyat siya, hindi pa pwede yun. Dapat across the value of the predictor, constant lang siya. Constant yung mean ng ano natin, ng residuals, at saka yung variance ng residuals natin. Okay? So, tapos din, dapat, sabi natin, diba, the constant mean, constant variance, tapos, independent siya. Okay? Independent dapat. At saka, okay, I'm having difficulty writing. Okay. Independent at saka normally distributed. And dapat homoskedastic siya, not heteroskedastic. And lastly, sabi natin, the explanatory variables, independent variables, they must not be collinear. No? Dapat, kung correlation titingnan natin, dapat mababa yung correlation. Okay. May question dito si Rob. Could you kindly share your question?
Yes, sir. Actually,
Pwede i-ano mo na lang. Sige. I-ano na, unmute ka na lang.
sorry, sir.
Yeah, sige.
Actually, I was just curious, sir, kasi in some of the previous studies, kasi parang one of the steps is for required me to establish correlation between variables.
Okay.
So, parang there was a study I did, pero parang eventually I used multiple regression. So, parang mali po pala na to use ano. My question is,
Correlation.
yes, sir. So the question is, multiple regression can't be used to establish correlation between variables and
Well,
different.
yeah,
Yeah.
thank you for that question. That's a good question. Actually, it can. Si multiple linear regression kasi kasama na yung correlation analysis doon. Correlation analysis will just tell us the type of relationship between two variables, the direction, no? Positive relationship ba yan or negative relationship? That's what correlation can do. Yun lang, no? Si multiple linear regression, it will tell us the type of relationship, whether it's positive and negative, and also it will tell us the magnitude of the relationship. Yun ang difference nila. Si correlation, hindi niya sasabihin yung magnitude, no? Hindi niya sasabihin na sa isang unit na nagbago si X, ilan yung units na magbabago si Y. Walang ganun sa correlation. That only happens in regression. So, si regression captures the correlation effect and also yung magnitude ng yung impact ng independent variable natin on the dependent variable. Okay? So, siguro yung study mo, kasi pag correlation study, ano yun eh, parang baliwala yan, no? Okay? If you're only dealing with the correlational study, sasabihin lang natin na pag tumataas si X, tumataas din si Y. Okay? Pag bababa si X, bababa si Y. That's what we call a positive relationship. On the other hand, a negative relationship is when X, okay, let me show that. The drawing natin. And Robbie, thank you for that question. So, ito si correlation, no? Kunyari, i-plot natin si Y at saka si X. So, kunyari, ito yung plot niya. The correlation will tell us ito kung ano yung nature ng relationship ni Y at saka ni X. Is it positive? Positive means when kung titingnan natin, no, ito, yung slope na to, positive relationship yan. Okay, bakit? When X increases, habang nag-i-increase si X, pag ganun, di ba? Y also increases, pag ganun si Y. Okay, so that's what we mean by a positive relationship. Okay? Also, itong line din to na pag bumababa si X, pag binabaan natin si X, ano mangyayari kay Y? Bababa din si Y. So in other words, same direction. When X goes down, Y goes down. When X increases, Y increases. That's what we mean by positive relationship. On the other hand, if we have this type of relationship, ito, pababa siya, di ba? So this is what we call a negative relationship. And the movement of the variables are opposite. Tingnan natin. Ito, pag ganito, papuntahin natin dito sa X, pa-increase natin. Saan papunta si Y? Take a look at this line here. Bababa si Y. Diba? So as X increases, Y decreases. Or tingnan natin dito sa kabilang side. Let's let X decrease. Diba? Ito, pinapababa natin si X going to the left. What happens to your Y? Nandito si Y, oh, tumataas. Ito yung slope natin. So in this case, as X decreases, Y increases. So opposite to, opposite direction. Ito same direction. So this is what the correlational study tell us. No? It will just tell us the direction. Ngayon, pag may regression, meron na tayong equation na Y is equal to beta null plus beta 1 times x. Itong beta na to, wala yan sa correlation study. It will appear in our regression study. So yung beta will tell us the type of relationship, whether it's opposite or the same, and also the magnitude of the impact of x on y. Okay, beta 1 will now tell us for every 1 unit increase in x, there's a corresponding beta units increase in y, ceteris paribus. Okay, Robbie, did that explain your question?
Yes, sir. Very, very much, sir. Thank you.
Yeah, very good, very good. Appreciate really that question. Buti na natanong mo yung Robbie kasi I was not thinking of discussing that, but that's a very good question because it ties in yung relationship ng isang correlational study at saka ng isang regression study. No? So the correlational study just tells us the direction of the relationship. A regression study tells us about the direction and the impact, the magnitude of the relationship. All right, very good. Okay, sige. So let me continue. All right. So if these assumptions are met, then we're able to generate what we call a blue model, no? Ano yung blue model? If the relationship between x and y are linear, tapos yung residuals natin, constant yung variance, the error terms are normally distributed, okay? So if they let's say if they do not violate these assumptions, then we have a model that's called the best linear unbiased estimators. Okay? Yung estimators natin, ito yung betas natin. Beta null, beta 1, beta 2, beta 3, etc. No? We have what we call the blue model. Now, when there are violations of the assumptions, then this is affected. So we'll take a look at this when we go to diagnostics. Kasi hindi, sabi natin, we will not stop just at being able to create the model. Madali yung model, class. 1 minute lang yan, tapos yan sa R, no? Which I'm going to show you now. So, mas ano dito yung ida-diagnose natin yung model. Alright, I gave here some, so tingnan na lang natin to maybe like this one. Control C, maybe I'll just show that. There are, of course, many other references. I just gave 2. No? Alright, so dito, okay, ito yung ano natin, equation, no, di ba? Y, the dependent variable is equal to your intercept plus beta 1 times x1 plus your residuals. Okay, ito simple linear model. Simple kasi isa lang yung predictor. Ito class, multiple, x1, x2. Okay. We said class, ito, pwede ito, no? Pwedeng si x1 naka-square root, naka-log si x2, pwede yan. Naka-squared siya. In fact, pwedeng may interaction, pwedeng x1 times x2, pwede yan. That will work sa model natin. Pero, if the beta is either squared or naka-log, yun ang hindi pa pwede, class. Okay, so I hope this is clear. Linear regression models can also include functions of the predictors, such as it can include transformations. Okay, it can include polynomial terms, cross products. Ito yung cross products, ito yung interactions. All right. So let me go back here. I think the other one, this one, okay, ito, ang binibigay nito class yung plot yata ng residuals. Okay, plus ko na lang. Okay, and key assumptions of ordinary least squares class. Key assumptions. All right. So we discussed this class, linear in parameters. Okay. The mean of the residuals is 0. No multi-collinearity or perfect collinearity. Homoskedasticity, no? And no linear relationship, no autocorrelation. Okay. Then, ito class, ito. Here. Take a look at the distribution of the residuals here. Ito yung homoskedastic. Constant variance. This one is heteroskedastic. Kasi as we go through the values of your predictor, yung x, no? Habang lumalaki siya, yung x, lumalaki yung variance ng residuals natin. Ito naman, while the value of x is increasing, then the residuals is decreasing. We don't want this. We don't want the residuals to be heteroskedastic because that will violate the assumptions, and then that will give us not the blue one. No? Okay? Hindi magiging blue yung yung model natin. Okay, ito yung sinabi natin kanina. The error terms should be normally distributed. All right. So let me go back to our model, to our notes. All right. So ito, let me just explain this further, class. The residuals epsilon sub I, E sub I is equal to the observed value minus the predicted value. Yung observed value, ito yung given value. Ito yung value na nakuha from surveys, no? Okay? This is your data minus the predicted value. Yung predicted value is the value that will be generated when we have the model. Okay? We will explain this in a while. And then sabi natin, okay, observed minus predicted. Okay, take a look at this, guys. Yung predicted, ang symbol natin dyan, y hat. No? So if you see that, may hat yung y nyo. So this is the actual value, y sub I, minus y hat. This means predicted value. Okay? So, hat yan, hat. Tingnan nyo kung paano sinulat, no? Backslash hat, y underscore I. No? Yung naka-hat yung y. Okay? Alright. Tapos, di ko nalagay yung dito. Sorry. The sum of the residuals, no? Ano dapat yung sum of the residuals? Ito, andito pala. Sorry, nasa ilalim. The sum of the residuals, we mentioned this a while ago, they will be 0. 0 yan, class. No? Bakit kaya nagiging 0? Kasi, take a look at the model. No? Anong nangyayari sa model, class? Diba? Ito yung natin, values. No? Tapos ito yung regression line natin. So, meron tayong magiging residuals positive kasi above the regression line, and meron tayong magiging residuals na negative because it's below the regression line. And if we get the sum of all this, itong mga residuals na to, no? Ito yan, no? Yung sum ng residuals na yan, lahat ng residuals, they will be 0. Yun ang isang nature ng isang OLS. Right? And also, may isang sinabi tayo dito na, okay, what we want is that the residual squared epsilon, ano ako magiging squared to, no? Yan. Epsilon squared dapat right. So ginawa ko lang minimum of the summation of epsilon squared. No? So dapat walang 0 to. Balik ko na. Dapat gumawa lang ako panibagong equation. Asa na ako? What happened? Okay, let's move on, class. I want us to at least have a simple linear regression. Okay, by the way, ito, no? This is related to what Robbie said a while ago. The slope has the same sign as the correlation coefficient. Di ba sabi natin, we can compute for the correlation between the dependent variable and the independent variable. And that's denoted by R. No? So magkaiba class si R. Si R is the correlation coefficient. Si beta naman, this is the slope. Okay, this is the parameter. This is the marginal impact of your independent variable on your dependent variable. Now, necessarily, si correlation coefficient will have the same sign as your slope coefficient. Kung si correlation positive, then the slope will be positive. If correlation is negative, then the slope will be negative. So it follows siya. No? All right. So let's now go here. Let's first try our first model. Simple linear regression lang aabutin natin ngayon. Okay. So let's load these packages. We have met these packages before. Tidyverse. Si Psychiata hindi pa. Si PaceText. OLS-RR hindi pa. Stargazer hindi pa rin. So let's use Pacman. I-load mo natin si Pacman. Tapos, para automatic na install yung packages at saka yung mga other packages na to, i-load na rin. Let's use the pload. Plus, clarify ko lang, we met this already, di ba? Itong pload ni Pacman before. Did we?
Yes, sir.
Okay, good. Sige. So, pwede natin i-run to, ito yung shortcut. Instead of doing install.packages, tapos library, matagal yun. Isa-isayin kasi natin yan. Ito. And then, if we want to check kung na-load na nga ba, tingnan natin tong packages dito. I'm going to check, for example, OLS-RR. OLS-RR. Ayan. Naka-check na yung OLS-RR ko. Which means, na-load na siya, na-install na siya, because it's here. And then, na-require na rin siya, na-load na rin siya, yung library ng. Okay, kindly check please yung Tidyverse, yung site, PaceText, OLS-RR, Stargazer. Kindly first take a look at them. 1, 2, 3, 4, 5 packages. And if they're all loaded already, kindly chat yes, which is just to confirm that indeed, yung pload na yan, package load from Pacman is able to, at the same time, install the packages if it's not yet there, and also load it. I'll wait for your confirmation, class.
Sir, only Tidyverse lang po yung naka-install sa akin.
Wala yung site?
Wala po. Wala
Sige
po
nga,
pati share screen po.
Pa-share nga screen, ha?
Sige po.
Stop share muna.
Wait lang po, sir.
Sige, Glenn.
Okay, ito
take your
po.
time. Okay.
Tapos po, ang naka-install lang po sa akin yung Tidyverse. Pero the rest po is wala. Like Psych, yung PaceText.
Wala rin.
Apo. And then yung OLSRR. Ay, wait. No. Mali yung spelling. OLSRR. Wala po. And then
Wala rin, ha?
Stargazer po.
Rinan mo naman yung buong chunk, ano? Sige nga, pakiran mo yung... Yan. Yung buong...
Run ko pa lang po.
Hindi mo pa linoad si Pacman.
Apo.
Oo.
Chinek ko lang po kung naka-install lang po or...
Hindi. What I meant was, you run it, and then i-check
okay.
kung ano. Yan. Sige, tingnan natin while you're here already, while you're there. Check na natin
yes
yung
po.
ano. Sige. Yan, nagrarun na siya. Kita mo, di ba? Nasa console. Nagrarun na siya. So, PaceText, ano na raw? I think loaded na, sabi. So here, thank you Alvin for asking that. Makikita natin, sabi ni Alvin kanina, walang Stargazer, walang Pastex, walang OLSRR. So let's see what happened to the Pacman payload package. Did it, tinan mo, OLSRR naka-install na dun sa console. So it automatically installed the package and also loaded it. No? Ayan na. Sige, check na natin. Sige, type mo ulit.
OLSLR.
Sige. OLSRR.
Ba't wala po siya?
Bakit wala OLSRR?
Psych. And then paste text.
Ba't hindi nag-a-appear? No?
Kaya nga po eh.
Dapat pero na-load na siya eh. Ayun, Stargazer installed.
Close ko na lang po then open ko po uli. Mag-work po siya ganun.
Sige nga, ulitin nga natin. I-run mo nga lang yung Pacman lang na ano. Yan. Yung
Ito po?
Yung next line. Yan
Ito.
lang, and we're there. Si control enter mo nga.
Control enter.
Oo. Tingnan
Wait.
natin. Sige, then yan, okay na siya. Balik nga sa packages.
Packages po. OLSRR. Joke.
Type mo lang O. Sige, O.
Bakit kaya?
Ba't kaya wala, no? Kasi na-install na siya eh. Di ba?
Close ko po siya tapos open ko po ulit.
Sige.
Save.
Save muna.
Tapos okay.
Yung iba class, kamusta?
Sir, same kami ni Alvin. Wala
Talaga?
din yung ano.
Okay sa akin, sir, na nandito lahat ang package.
Okay.
Ay sir, pagka-restart, nung inopen ko po ulit, nandito na po yung OSLRR, yung
Okay.
psych.
No, inopen mo ulit, no?
Apo.
Okay. So, pero dapat automatic yan na magre-reflect dun eh. Pag
Yun
linod
nga
mo.
po.
Okay. Anyway, sige, good. Alright,
Yun po.
so, sino pa yung isang ano?
Thank you po.
Subukan mo nga i-save muna, i-close mo tapos i-open mo.
Sige po, sir.
Sige. Ikaw ba yung Mark?
Yes po, sir.
Sige, paki-check nga.
Pass. Sir, parang hindi pa siya nakatick yung box. So, kailangan ila-library ko po.
Ano mo nga, Mark, is pwedeng paki-share yung screen.
Sige po, sir.
Si OLSRR nga pala class, very powerful yan sa stepwise regression which we will be discussing. So naran mo na yung code natin, yung 99 to yung si Pacman, naran mo na yan?
Yes po, sir.
Sige.
Kasi parang yung OLSRR, sir, di pa
Oo nga, no? Bakit hindi siya nakaklik? I-run mo nga ulit yung second line, Pacman.
Ito, sir.
Yan, okay. Control enter mo. Ayan, nag-run na siya, no? So dapat ayan, no? Tingnan mo, nag-click na yung OLSR.
Oo nga.
Diba?
Sige,
Dapat ganun eh. Kasi itong payload na to, it will both install at saka yung load, yung package. Tingnan mo nga, Mark, tingnan mo si Psych.
Si Psych po, sir.
Oo, tingnan natin si Psych. PSY. Ayan, no? Naka-load na siya, no?
Stargazer.
Sige, Stargazer. Yan, okay na.
Okay na din, sir.
Good. All right, thank you.
Thank you, sir.
All right, thank you for those questions, class. All right, so let me share screen again. Okay, anyone else who has a question? I hope nag-run sa inyo, no? All right, let's go now. Let's go here. Now, recall, class, that we loaded this data set, no? So how do we load the data sets? There are several ways. One way is externally, you have the file yourself, and then we can load it or we can load it from the packages, diba? Some packages come with preloaded data sets. So in this case, we're using an external file, yung wage CSV natin. Before we load CSV, tingnan muna natin tong So read R, tingnan muna natin tong package na to. There's a powerful package called read R, which comes with, this comes with tidyverse. Tingnan natin si read R, kaya dito, pwede na pala dito, packages na lang. Tapos you should have also read R, no? Read, oops, yan na. Pero dito ko na lang i-type sa packages na lang para mas mabilis. Here, read R, yan, naka-check na, no? Kasi this comes with, this comes with tidyverse. So click natin to, yung read R. Alright, then, I will not go to the descriptions, but read R, in read R, you can, tingnan natin dito, you can load data sets, no? Take a look at this. Pwedeng read R CSV, read underscore CSV2, read underscore delim, read file, read table, etc. No? So ang gagamitin, what we're going to use is this one, read CSV. Okay, so what does this do? Read a delimited file. Ang ibig sabihin ng delimited file, may mga spaces between the, let's say, the variables or the columns. No? Okay, so it can be comma-separated values or tab-separated values. So dito sabi, we will read a delimited file into a table. If you recall, yung table class, it's a special type of data frame. Okay, so here, andito si read delim. Okay, so sa atin, alam naman natin na CSV siya, so we can use this. No? Read underscore CSV. Okay, so we will not go into all the details here. Pero ito lang yun, no? Read underscore CSV, kung ano yung file. Tapos, column names, meron bang mga may mga, okay, ano pa? Actually, yun lang kailangan natin. Okay. Column names is equal to true. Ibig sabihin, may mga headers ba yung natin? yung data natin. Okay, so let's import, no? Okay, copy lang natin to. Yung column types, kasi pwede nating sabihin kung anong type dapat yung mga columns. No? Like Control-Shift-M, Control-Alt-I. Control-Alt-I, remember that's your code script, code chunk na shortcut. All right. Control-X. Okay. Note class that we don't have yet the wage data. If you take a look at our global environment, wala pa tayong nado-load dito na data, wala pa tayong nakikreate ng object. So what we're going to do is we're going to use this yung wages natin na CSV file to load it. So let's create this object, wage na lang. No? We're going to name this object wage, and then we're going to use read underscore CSV. And just to remind you, this is from read R, no? Read R, read CSV, and ano yung file? Now, the good thing about what we're doing is that since we're working in a project, tapos andito yung file natin, we don't need to specify kung ano yung file location niya sa computer natin. Okay, since andyan naman siya, no? Right, so wage.csv. Since it's already loaded dito sa sa folder natin, susulat lang natin wage.csv. But if this was in another folder, then we will have to put here the file location. Kaya nga importante yung project kasi it will facilitate the loading of the data, etc. No? And then comma, column names is equal to true. Ibig sabihin, if I'm not mistaken, may column kasi itong wage, may mga names siya, and then ito true natin. So let's see first. Let's run this. And then the object should Yan. Okay? So this is what the tapos andito, no, guys, nasa object na natin dito, nasa data na natin, si wage. So since it's already here, we can now make use of this wage data set. So it gives us some description about our data. Rows, there are 526 rows and 8 columns. Ang delimiter natin, comma, CSV kasi, no, comma separated file values. There are 3 variables that are character, race, gender, civil status. There are 5 variables that are double, di ba? Numeric siya, no? Education, experience, tenure, number of dependents, and hourly wage. All right, so let's not mind the others. So what we can do now is, close ko na muna to, and then, tingnan natin data natin. We can use view. Okay, pag ginamit natin view, it's just the same as clicking this one. View, wage. Let's take a look at our wage data set. So ito yung wage data set natin. No? So you have education, experience, 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. 3 of which are character. Character na, which we can use as categorical variable. Kasi, they can be used to classify, no, our observations. Race, gender, civil status. And there are 526 observations. Okay, class? Any questions so far about our data? Right, of course, we can, let's take a look also. Before you do anything, examine muna natin data natin. So how can we examine? Control Alt I. We can make use of the structure, di ba? Structure. Okay, so yung data natin, it's a data frame. You know what a data frame is, di ba? Rectangular siya. May names yung columns, yung pati mga rows. Then we have here our variables, education, experience, okay, tenure, race, gender, civil status, number of dependents, and hourly wage. So meron tayong 3 character variables at saka 5 numerical variables. So that's what the structure will give us. Tapos yung summary naman will give us the summary statistics. So we have education, no? Andiyan yung minimum, maximum, first quartile, second quartile, third quartile, and then the average. Now, ganun sa lahat ng mga numerical, ibibigay yung 5-number summary plus the mean. And then sa mga characters, depende kung anong klaseng character. Pag simple lang na character, it will just give us the count, no? Yung length niya. Ang length dito, ibig sabihin kung ilan observations. So hindi sa atin binibigay yung frequency, yung distribution ng kunwari gender class, no? Male, female. It does not tell us kung ilan yung male at saka yung female. Okay? Kailan lang mangyayari yun? So let me illustrate that. No? Let's see. I'm going to create another object called wage1, and it's equal to wage. So magkikreate ako ng isang object na wage1, okay? Na sa wage din actually siya. So now, you'll see that dalawa na yung ano natin dito. No? Pareho lang yan, si wage at si wage1. But I purposely did that because I want, for example, to show you, okay, yung structure natin, ni wage1, I just want to show you something here. So si wage1 natin, alam natin na we know that si race at saka si race, si gender at saka si civil status, they're all characters. Okay, now what I'm going to do is I'm going to change. Kunyari si race. Si race gagawin kong categorical variable or factor. So how do I do that? So from my wage 1, okay, then $sign. Notice when I type $sign, lalabas yung mga variables yan. Raise. Yan. Alt minus. Okay, what I'm going to do is I'm going to make it a factor. As that factor. So wage $1 raise. Okay, so what am I doing here? I'm telling R, si wage 1 raise, okay, yung variable na raise dun sa wage 1 wage 1 object should be converted into a factor. Okay, so let's run this. Control Enter. And then let's once again take a look at the structure of wage 1. So ano nangyari kay raise? Now look, class. Si race, naging factor na siya. Si gender, tsaka si civil status, character pa rin. Pero sinabi sa atin dito, race has 2 factors, non-white at saka white daw, no? So if I get the summary, i-summary ko, summary of wage 1, you notice what will be the difference. Okay. Tingnan nyo yung race natin, class. Race, since factor na siya, di ba? Nag-frequency distribution na siya. Okay? A minute, class. Dali lang. Okay? Any questions? Clear ba so far? Kita natin difference ano kapag factor at saka kapag character lang, no? Kapag character, bibilangin lang 'yan kasi character lang siya. Pag factor, it's bibilangin niya kung ilang levels, kung ilang how many levels of the factors and then magfi-frequency count siya. Okay, clear so far, class, yung ano, yung factor na 'yan. Tapos, isa pa nga pala, sa regression, pwede natin magamit yung variable na raise kasi factor yan. Okay? If a variable, if a character can be converted into a factor, i-convert natin para magamit siya sa, sa regression, if we're performing regression. Okay, so, alright, so let's just continue. Okay. There are other functions that can give us some summary statistics. For example, si psych meron siyang describe. Tingnan nyo nga, class. Let's see what happens. Okay, sorry about that, class. So si psych, meron siyang describe na function. Tingnan natin. Psych, describe, okay? And then si wage, no? All right, take a look at this. This will give us a descriptive statistics. All right. 8 rows, 13 columns. So ano yung mga pinakita dito? So variable 1, yung count niya, kompleto, walang missing values. Yung mean, of course, itong mga gender, race, civil status, walang sense or walang value mean nila kasi hindi mga characters naman yan no? Or factor. Standard deviation, median, trimmed median, mean absolute deviation, minimum maximum. So meron pa diyang skewness, kurtosis, range, standard error, etc. So this is one example of a functionality of coming from a package, site package, no? Yung describe na function lang, mabibigyan na tayo ng mga computations. All right. And there are others. No, we will look at the others as we go on. Ang gusto natin muna ngayon is so descriptive stat. Balikan natin ang next meeting. I'm anxious to at least start with a simple linear regression. How about plotting? Okay, di ba kasi sabi natin, we want the relationship between the dependent variable. In this case, we're studying the hourly wage. Gusto natin makita, gusto natin i-model si hourly wage. We would like to know if this variable, si education, si experience, si tenure, yung mga factors na to, number of dependents, if they have a relationship with hourly wage. Okay? So, as a start, ang gagawin natin, tingnan muna natin si education, no? And hourly wage. We'd like to see if education is related to hourly wage. May ano ba? May effect ba ang number of years ng education sa hourly wage sa data na to, no? There are 526 observations. This is actual data. Because I think 1972. I just forgot where. Hindi ko lang nalagay kung saan kinuha to. I think this is US data 1970. These are in dollars. These are in dollars per hour. Per day ba to? Per hour? I'm not sure, but this is dollars, no? All right. So what we're going to do now, let's first see the relationship between education and hourly wage. Now I gave you this code already. So i-plot nga natin on the x-axis is education kasi siya yung independent variable natin. On the y-axis is hourly wage, siya yung dependent variable natin. And then yung plot natin, lagyan natin ng pangalan, main is equal to scatter plot of hourly wage and education. All right, kindly run that class and tell me what happened.
Error po sa akin, sir. Pero
Error?
not sure po kung
Okay.
bakit.
Yung iba nag-error din?
Error, sir.
Error din po sir sa akin.
Okay,
Error
tama.
din, sir.
I was expecting that to be error, no? Bakit?
Object educ not found po yung nakalagay sa akin.
Yes, tama. Kasi tingnan niyo ang mga objects natin dito. May educ ba dito? Class? May hourly wage ba dito? Wala. And then
Wala
you're
po.
telling R to plot education. So hindi niya alam yan. Ano yung education na yan? So we have to reference this, no? So this will not work. However, copy na natin itong Control C. Copy ko lang sa ibaba. Okay, so we have to put here wage $sign. Okay, kaya nga class yung ano natin, yung sa structure natin, nakita nyo may mga $sign. $educ. Ibig sabihin nun that object is coming from wage. So dapat ilalagay natin dito yon, no? Yan. Wage $education, wage $hourly wage, no? Unahin natin lagi si x-axis tapos si y-axis. Unahin si dependent variable tapos si independent tapos si dependent. Okay, lagyan natin ng x label, no? Ang x label natin is years of education. Lagyan natin ganon. Okay. And then y label naman, y label is equal to I think this is hourly wage. Okay. All right. So take a look at our function. Plot is the simplest, no? Simplest data visualization function in R. So sabi natin dito, i-plot niya si wage education, x-axis, hourly wage, y-axis, And then, lagyan na ng label yung x-axis at y-axis. Tapos yung main plot, lagyan na rin ng label na to. So let me go anywhere here to this code, to this part of the code. You don't have to highlight everything anywhere in that line. Kunyari, punta ako dito. And then control enter. So, magpa-plot yan. Ito yung plot natin. Yan. Okay? So you can see here, andito yung hourly wage, yung pangalan ng Y label natin, Y-axis, ito yung X-axis natin. Tapos ito yung scatter plot, yung main title. Scatter plot of hourly wage and education. Okay, as you can see, medyo it's so difficult to say kung ano. May pagka-linear, no? May pagka-linear. So parang let me annotate this again. So if you're going to look at a possible line that will describe hourly wage and education, medyo ganito, no? Although hindi masyado, no? So we can say that there seems to be a sort of a linear relationship between hourly wage and education. We would want our y, our dependent variable, and our x, our independent variable, to be highly correlated. Okay, pero ganito, we'll still use this. Tingnan natin kung what will happen. All right, my chat. Thank you, Rob, for that question. Yung fanning out will be for the residuals. No? Okay, we use that term to check the variance of your residuals. In this case, hindi siya hindi siya technically we can still describe this as fanning out. No? Okay, pero as I said, ang context ng paggamit natin ng fanning out, we don't want the residuals, the variance of the residuals to behave that way. Ito naman hindi, kasi actual data to, no? So, yung data ni hourly wage at saka education, pairwise, ito yon. All right. So, let's take a look at the correlation. Kasi, ano ba yung correlation na to? Madaling computin sa R yung correlation. So, let's go here. Ito, correlation. Control Alt I. Core lang, no? Core ng, again, dapat andyan wage education at saka wage hourly wage. Yan. Kasi hindi natin pwedeng ilagay core tapos education lang at saka hourly wage. Okay, by the way, class. Kasi run na natin to. Okay, so it's 0.4, no? Around 0.4. So, yeah, pretty moderately strong yung relationship nila, no? Moderately strong yung relationship ng hourly wage at saka ng education. Okay, did you get 0.4, class? Ito?
Yes po.
Okay, good. Good. So we can say that moderately strong naman yung relationship nila. All right. So we now go to regression. Ito yung at least aabot tayo, no? At least yung simple regression natin. We will now regress si hourly wage on education. So riniregress natin yung dependent variable natin, no? Hourly wage. Re-regress natin siya dun sa education. So the function that's used is LM. All right. I'll leave you, class, to run this yung question mark LM para sa help function. Okay. So let's do the model now. Control Alt I. All right. So when you do regression in R, we use the LM function. Yan. Madali lang, no? LM. And then we identify the dependent variable. Ito hourly wage. And then hourly wage regressed. Yung regressed is tilde. No? So that shift nasa upper right, nasa taas ng tick mark. LM of hourly wage regressed on education. Okay. And then data is equal to wage. All right, take a look at this. No? So ito, notice I didn't put here wage, $hourly wage, kasi dito siya sa dulo. So what am I telling R? I-model niya nga, i-model niya si hourly wage on education. Alright? So let's run this. Okay. Then what do we have here? Andito na, class. Andito na yung model natin. Ito. Ito yung beta null natin, yung intercept. Ito yung beta 1 natin. This is now the parameter for education. Okay? This is the marginal impact of education on hourly wage. And it's positive, which means the sign of the beta will also be the sign of the correlation. Kung positive tong beta natin, si correlation positive din. Which means that as education increases, hourly wage also increases. All right. Now what we're going to do is, ano ba ang laman nito? No? Itong ano, hindi natin kasi, the better way to do this, is create a model out of this. Create an object. So I'm going to create an object, call it mod1. Okay, model 1, it's up to you to really name it the way you want. No? Mod1, and then i-run natin to. Sige, run natin. There we go. So nagkaroon ngayon ng ano dito, ng object na mod1. Yan, class. And mod1 is a list. Yun yung list of 12. 12 yung laman niya. If I click this, lalabas siya dito sa window dito. No? Ito yung mod1. If I click this, so matatago yung laman. No? This one will generate what's inside here. Tapos tingnan nyo class yung mga objects niya. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No? 12 lahat. No? 12 lahat. So yung coefficients, if you take a look at this, yan. Intercept, ang type niya double, education double, yung intercept negative 0.9, yung education 0.54. And then here we have residuals. 526 lahat ng residuals. If I click this, okay, ilalabas niya lahat ng mga values ng residuals. Babalikan natin to class kasi residuals are very important, diba? It tells us these are the errors, no? Okay? And then may iba pa, no? There are other things here which we're going to look at, yung iba, at least yung iba dito. Okay? But suffice it now to say that, so ito yung model 1 natin, ito yung regression output natin. And then if we take a look at names, no? Names ni mod 1, ano ba yung laman ni mod 1? Oops. Nangyari dito, control Z. Names ni mod 1. Yan. Yan. Ito yung mga laman kanina, di ba? These are the contents of mod 1. And we can, for example, mod 1, dollar sign, di ba? Dollar, lalabas yung mga laman ni mod 1. If I want to access the coefficient, tab ko lang siya, mod 1 coefficient, control enter, it will generate the coefficients. Okay, so many things that we can do about this model. No? All right, so let me insert another code chunk. And then one important function that we can do is to summarize mod 1. Okay, let's see what happens to summary mod 1. Run natin to. Okay. So we have this. Summarize natin. So this is the whole output of your regression. Tingnan natin ha. First is the formula, no? Hourly wage regression education using the data wage. And then here you have the 5-number summary of the residuals. Makikita natin dito na ang minimum is negative 5.33, ang maximum 16.6. So merong mga residuals, may mga values na medyo nasa taas, no? Kasi mataas yung ano nito, mataas yung maximum. Okay. Then we have here, what's this? This is now your value of your parameters. This is your beta null. Ito yung intercept natin. This is your education. And you also have here some other information, standard error, t-value, and the probability. Okay. So this one, ito class, itong portion na to, okay, this is your individual t-test, no? Test of means to it, ito yung t-value. Okay, so let's interpret this one by one. Okay, ang value ng intercept natin is negative 0.09. Okay, and then we have here the p-value. What's the p-value of, so this is beta null, no? And this is beta 1. Ang p-value natin for the intercept is 0.187. Okay, so what do we do with this? If you recall from your other stats, i-compare natin to sa level of significance, no? Level of significance. And usually, on level of significance, the default, if it's not identified, it's actually equal to 0.05. Ito yung level of significance natin. So what does this mean? We're going to compare the p-value, itong 0.187, okay, with our alpha. So, sorry, let me call this alpha. And this one, our p-value is equal to 0.187. And the rule is, when the p is low, L-O-W, low in comparison with your alpha, the null must go. Ulitin ko when the p is low, the null must go. Para madali maintindihan. So dito, the p is, the probability is 0.187. And it's greater than 0.05. It's not less than 0.05. Kasi pag sabi natin low, dapat less than 0.05. No? Okay, so since p is greater than 0.05, ang conclusion natin, we fail to reject our null hypothesis. No? Okay, what's our null hypothesis here? Dito sa individual t-test, ang null hypothesis natin dito is that, let me write that. So for the first null hypothesis, beta null is equal to 0. Okay, so ang tinetest natin dito kung si beta null, and beta null refers to the intercept, no? If beta null is equal to 0. Alright, so anong conclusion natin? 0.187 yung probability. We benchmark it with the alpha, which is 0.05. Since si p-value hindi siya lower than 0.05, hindi natin pwedeng i-reject yung null hypothesis. Ang ibig sabihin ng null must go, i-reject natin. Okay, let me repeat. Okay, that the t-test for the intercept, the t-value for the intercept is negative 1.321, and it has a corresponding p-value of 0.187. Okay. Now the p-value is greater than 0.05. So we fail to reject the null hypothesis. We fail to reject the null hypothesis that is that the beta null, the intercept, is equal to 0. Okay? All right? Okay. Now, ito naman. Itong pangalawa, beta 1. Ang null hypothesis natin, beta 1 is equal to 0. So how is that? The p-value is, ano tong 2e to the negative 16? Ano ibig sabihin yan? 2e. And then may negative 16. And then merong tatlong stars dito, no? So I'll just explain this and then we will continue with this next meeting. And reminder ng class, 8:30 tayo next meeting to compensate for whatever we will miss here. All right, this is in scientific notation. Ang ibig sabihin nitong negative 16 na to, okay, magsisimula tayo sa 2, kasi may 2 tayo dito, no? 2, and then we will move 16 place, sorry, mali. Magsisimula tayo sa ano dito sa decimal point na to. And then you move 15 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 15 places to the left. And yung pang 16, 2 ang ilalagay natin ito. 2. And then put here zeros. So it's a practically very small number, 0.000000. 15 zero tapos 2. And therefore, we know that that's less than 0.05. So, ano yung inference natin dito sa null hypothesis na to for education? Our inference is that, ano yung inference natin dito? Do we reject or do we fail to reject? The answer is, we reject the null hypothesis that the slope for education beta 1 is equal to 0. Reject natin to. Meron tayong evidence, we have strong statistical evidence to show that beta 1 is a value other than 0. Okay, and then take a look at this. Ito walang asterisk, ito may asterisk. Clear ko muna siya. Ano ibig sabihin itong asterisk na to? Dito natin makikita yan. No? Here. Yung asterisk, yung 3 asterisk niyan, ito. So, ito, titingnan natin yung right nasa kanan nito. 3 asterisk means that what? Itong 2 asterisk, dito yan, 0.01. Itong 1 asterisk, 0.05. Itong dot, 0.10. So it ranges between 0 and 1. So ang ibig sabihin nito, that our P is significant at 0.001 level. Okay, significant yung P natin at 0.1%. Kasi nga, itong P value natin is much less than 0.001. So this one will tell us yung level of significance. Kung 3 stars, significant siya at 0.001 level. 2 stars, significant at 0.01. 1 star, significant at 0.05. And then yung dot nito, significant at 10% lang. All right? Okay, so let me stop there. Okay? Stop there. And then tuloy na lang natin to next meeting, no? Okay. Any questions, class?
Sir,
Yes?
si Mark.
Yeah, Mark.
Sir, kasi next week, nakalagay sa uni calendar natin, EDSA Revolution Anniversary. Holiday ba nun, sir? Or papasok?
Oh,
tayo?
hindi ko alam, ah. Let's take it from kung ano yung sasabihin ni school. No?
Okay, sir.
Kung ano yung official na we will have to follow. Kung ano yung kung may class, magka-class tayo. Kung walang class, then hindi ako pwedeng mag-class na pag sinabi ng school na walang class. Eh. Kasi mamememo ko.
Sige po, sir.
Okay, I hope so far okay naman yung discussion so far. Okay?
Yes, sir.
Oo nga eh. Yeah, usually non-working holiday. Tingnan natin, let's see. Okay, thank you so much, class. See you whenever.
Thank you po.
Thank you, sir.
Thank you.
Sir.
I'll post this recording. Yes.
Si Richard po, may attendance po kaya?
Ay, hindi na ako nag-attendance, Richard.
Okay. Sige.
Sige. Thank you.
Thank you, sir.
Sige,
Thank you po.
Thank you, everyone.